Yes, very good afternoon to one and all present here for the today's GATE training on 2021. I am Abhilash BL. I will be the master of ceremony for the today's event. And today's topic on GATE 2022 will be on municipal solid waste. I welcome Roopapriya J K ma'am for the session.
Thank you.
It's my privilege to introduce Ms. Roopapriya ma'am to the session. She did her graduation in Environmental Engineering from VVCE Mysuru and Master of Technology in Environmental Engineering from Press College of Engineering, Mandya. She is currently working in VVCE Mysuru from past 15 years. She was working as a training and placement officer for 8 years in VVCE and one around 2 years of experience in Central Pollution Control Board, New Delhi. I welcome you to the session and over to you, ma'am.
Thank you so much, Professor Abhilash, for that introduction. I would like to greet all the GATE aspirants and all audio viewers, and welcome to GATE 2022, Session 1 and Day 13. GATE syllabus framed for civil engineering domain includes 12 specialization. I wish to share my slide with you. Welcome to GATE 2022. And our topic for today is Municipal Solid Waste Management, which is on this day, 29th of November, 2021. And I'm Roopapriya J K. The GATE syllabus framed for civil engineering domain includes 12 specialization, and environmental engineering is one of the specialization, which includes all these three main domains: water and wastewater quality treatment, air pollution, and municipal solid waste. Based on the previous question papers, this was the pattern under environmental engineering. The paper in 2020 had 19 marks and 12 questions under environmental engineering, and the previous paper that was on 2021 had 15 questions for 19 marks. This is for your information. So municipal solid waste has various topics under it, and we have the types of solid waste management and characteristics of solid waste management included here. So this session on municipal solid waste consists of all these topics under our discussion. So we will have types of solid waste, generation of solid waste, collection and transfer and transport of solid waste, reuse, recycle, energy recovery, disposal of solid waste as well. The human interaction with the environment has always resulted in waste production. So this waste is nothing but any unwanted or unusable material, and this can be considered as a substance or object which are disposed of or intended to be disposed of or are required to be disposed of. So this is the meaning of waste. So what is solid waste? Solid waste is a range of garbage that comes from offices, homes, industries, and agriculture or other commercial activities that are deemed unwanted or no longer useful. So now, why have this solid waste management gained importance? Now, because of the increasing generation of solid waste, this solid waste management system or the process has gained importance. So, solid waste management is the system of administration that manages the activities of collection, source separation, storage, transfer and transportation, processing, and treatment and ultimate disposal of solid waste. Municipal solid waste management. Municipal solid waste management has certain goals, and the goals are to promote the quality of living and environment, to generate employment and income, protect environmental health, and support the efficiency and productivity of the economy. The functional elements of municipal solid waste management systems include waste generation, waste handling, separation, storage, and processing at source, collection, transfer and transport, separation and processing and transformation of solid waste, and ultimately disposal. These functional elements are further explained as generation of solid waste, which encompasses of all the activities in which materials are identified as no longer being of value and are either thrown away or gathered together for disposal. The on-site waste handling, storage, and processing at source includes all those activities which are associated with management of wastes until they are placed in the storage for collection. Handling these wastes also encompasses the movement of loaded containers to the point of collection. The third functional element of municipal solid waste management system is collection. Collection of solid waste includes not only the gathering of solid waste and the recyclable material, but also the transport of these materials after collection to the location where the collection vehicle is emptied. The fourth element is transfer and transport, and it involves mainly two steps: transfer of those wastes from the smaller collection vehicle to the larger equipment. And the second one is subsequent transport of these wastes, usually over long distances to a processing or a disposal site. Our fifth element is separation, processing, and transformation of solid waste. This includes the recovery of all those separated materials, separation and processing of solid waste components, transformation of solid waste that occurs primarily in locations away from the source of waste generation. And this is actually the fifth element of the municipal solid waste management system. The last one is the disposal, and it includes all the activities which are included in the ultimate disposal of the solid waste. So today, the disposal of waste by landfilling and land spreading is the ultimate fate of all the solid wastes. And the questions related to this could be something like this. Or you may be asked question on what are the steps in management of municipal solid waste, and these could be the options. The first option could be the generation, collection, handling, transport, and treatment, and the second, generation, handling, collection, transport, and treatment. Treatment, generation, handling, collection, transport is the third option, and the fourth option could be a combination of generation, transport, handling, collection, and treatment. And as we know, the six elements of municipal solid waste management, we know the actual path of municipal solid waste management, and this is the answer for the question steps in management of municipal solid waste management, which is the second answer, that is generation followed by handling, collection, transport, and ultimately the treatment. Moving on to municipal solid waste management rules. In response to public interest litigation, the Honorable Supreme Court of India constituted a committee to recommend suitable guidelines for solid waste management in Class 1 city. And this committee submitted the recommendation in the year 1998, and MOEF actually issued a draft MSW rules, that is Municipal Solid Waste Rules 2000 in 1999. Upon finalization, MOEF issued final Municipal Solid Waste Management Rules in September 2000. And this is the Municipal Solid Waste Management Rules, which we call it as Municipal Solid Waste Management and Handling Rules 2000. And these are applicable to every municipal authority responsible for collection, segregation, storage, transportation, processing, and disposal of municipal solid waste. This rule contains 4 schedules, and these are the different schedules under municipal solid waste rules. Schedule 1 relates to the implementation schedule. Schedule 2 relates to the specifications to collection, segregation, storage, transportation, processing, and disposal of the municipal solid waste. Schedule 3 is the specifications for landfilling, indicating site selection, facilities at site, specifications for landfilling, pollution prevention, water quality monitoring, ambient air quality monitoring, plantation at landfill site, closure of landfill site, and post-care. And the last Schedule 4 indicates waste processing options, which includes standards for composting, treated leachates, and incineration. So these are the 4 schedules of municipal solid waste management rules. Now, the question related to this topic would be the municipal solid waste regulated through the Act. So which is the Act and which year was it regulated? And the options could be as such: Municipal Solid Waste Management and Handling Rules 2000, Environmental Protection Act 2000, Municipal Solid Waste Act 2005, or none of these. So we have the answer as the Municipal Solid Waste Management and Handling Rules 2000, and this is the answer for the question when the Municipal Solid Waste Rule was regulated. Types of solid waste. These are the different types of solid waste. We have 2 major categories under the types of solid waste. One is the non-hazardous waste, which includes municipal solid waste, agricultural solid waste, and industrial solid waste. Industrial solid waste is again subdivided into construction and demolition waste, medical waste, special waste, and even the treatment plant waste. The second category is hazardous waste, and here again we have subcategories such as household waste and industrial waste. And industrial waste is again subcategorized as listed industrial waste, universal industrial waste, characteristic waste, and mixed waste. So these are the different types of solid waste. If we have to take only municipal solid waste as an example and identify the sources and the types of municipal solid waste generated regularly, so we have again different sources and different types of solid waste coming out of these sources. One is the residential, commercial, institutional, construction and demolition, municipal services, and ultimately the treatment plant sites and municipal incinerators. So these are the different types of municipal solid waste. Next is the characteristics of solid waste. The characteristics of solid waste includes physical, chemical, and biological characteristics. Physical characteristics of solid waste includes the specific weight of the solid waste, the moisture content, particle density, particle size and the size distribution, field capacity, and permeability of compacted waste. Under chemical characteristics of solid waste, we have proximity analysis, fusing point of ash, ultimate analysis, and energy content. Under biological characteristics, we have biodegradability of organic waste components, production of odor, and breeding of flies. So this is our physical characteristics of solid waste. We shall discuss each and every characteristic separately and in detail. To begin with, we have the specific weight of the solid waste, which we also call as the density of solid waste. So here specific weight is defined as the weight of a material per unit volume, and it is expressed either in kg per meter cube or pound per feet cube or pound per yard cube. So these are the different units used for the specific weight of the solid waste. We normally use kg per meter cube as our reference unit. Specific weight data are often needed to assess the total mass and volume of the waste that must be managed, and it usually refers to the uncompacted waste, and it varies with geographical location, season of the year, and length of time in storage. These are the specific weight values, or we call it as typical specific weight values. And there are different components and the range of specific weight specified according to this table. And we usually refer to the typical value, and we use this in the estimation of the specific weight of the solid waste. So here you can see the components such as food waste, paper, cardboard, plastic, garden trimming, wood, and tin cans. There are many more components, but these are generally taken for any calculation of the specific weight of municipal solid waste. And you can also observe the range specified in kg per meter cube and also the typical specific weight mentioned in the last column for all these components of the solid waste. How do we estimate the density or specific weight of municipal solid waste? So these are the type of questions which are normally expected in GATE question paper. So now if the question is something like this, estimate the as discarded density of a solid waste sample with the composition as given below. So you can observe that the components which was mentioned in the previous slide with the typical density is given in this problem. And another column has been inserted here, which we call it as percentage by mass. And we also have the typical density in kg per meter cube. So this is the question asked in most of the question papers, where you will have to estimate the specific weight or density of the solid waste using this data given in this particular question. So how do we evaluate or how do we estimate this? So there are different steps which we have to follow, and these are very simple steps. So the first step is to calculate the volume in meter cube. We have the values of percentage by mass in the tabular column, and we also have the typical density. Using these two values, we'll have to calculate the volume for each and every component of solid waste. So after we calculate the volume using the values given in table, the second column and the third column, for each and every component, we have different volumes. And we have to finally find out what is the total volume of all these components of solid waste. So according to this calculation, we have 1.107 meter cube of volume of the solid waste coming out of these components which are mentioned in this table. That is the food waste, paper, cardboard, plastic, garden trimmings, wood, and tin cans. After calculating the volume, now we have to calculate the density or the specific weight, which is calculated using the formula total weight divided by total volume. According to this question, the total weight is 100 and the total volume which we have estimated is 1.107. Now our specific density or specific weight of the solid waste component is 90.33 kg per meter cube for these components given in the problem. So this is the solution to our problem where we are estimating the specific weight or the density of the solid waste. So this is one example. Let's take another example to have a better understanding of how do we calculate the density or the specific weight of solid waste. So this is another question similar to the previous. Here again, we have to estimate the as discarded density of the solid waste sample with the composition given in the table. So here the density values have been changed. The components are the same and the percentage by mass is also taken into consideration. So as discussed previously, the first step is to calculate the volume. So the volume is calculated using the formula percentage by mass divided by the typical density. And we get the last column, which is the volume of all these components of solid waste. And the total volume in meter cube is 0.649 according to this given table. With this, the step 2 would be to calculate the specific weight using the total weight of the solid waste components and the total volume, which we have just calculated. So according to this, we have the total weight as 100 and the calculated total volume is 0.649 and the specific weight of solid waste for this particular given problem is 154 kg per meter cube. So this is the solution to our problem number 2, which is evaluation of the specific weight of solid waste. Let's take another example. This is a slightly different question where the composition of the municipal solid waste has been given and you've been asked to calculate the specific weight and there are choices given for the answers. So this is how it goes. The composition of a certain municipal solid waste sample and the specific weights of these various components are given below. And the question has, again, 4 different answers. We have to identify what is the answer for this particular question. We have 4 components. Now, according to our solution and the steps which we have to follow, we have to first calculate the volume. Now, when we calculate the volume for this particular question, we have the total volume generated by these components as 0.456 meter cube. And we have to calculate the specific weight, taking into consideration the total volume which is calculated. With that, we have 100 divided by 0.46, and the answer is 217 kg per meter cube. So we have the answer as 217. The next question is to estimate the average and bulk density of solid waste. So this is the question given, and this has 2 subsections. One question is on the average solid waste, and the other one is the bulk density of the solid waste. So we have 2 questions. This is the exercise given in some of the books. So the components are food waste, paper, plastic, and metal. The percentage by weight is given, and the typical density is also mentioned in this question. 4A is a question on what could be the average density of this solid waste components in kg per meter cube. And the second question is what could be the bulk density in kg per meter cube prior to the compaction of the solid waste. So let's see how do we evaluate this. Step 1 is we already have the percentage by weight of these solid wastes, or which we can refer this as Fi. We also have the typical density in kg per meter cube. We can refer that as Di. And now to calculate the average and bulk density, this is the simplest way of calculating, average density, where we have the average density as the summation of Fi and Di, that is the percentage by weight of the solid waste, into the typical density in kg per meter cube. And the bulk density in kg per meter cube is calculated using this formula, where we have the summation of Fi by Di in the denominator, and on the top we have 100. So let's calculate. So based on this, we have the average density calculation in our fourth column, which gives the total average density in kg per meter cube. We also have the bulk density, which is calculated using the column 2 and 3, that is Fi and Di, that is Fi divided by Di gives us the bulk density of all these individual components of solid waste. And this is the summation of the average density and bulk density. The total average density is 230.7 kg per meter cube, and the total of the bulk density in kg per meter cube is 0.595 according to this question. Now to the solution. Now, because we have 4 different options to select our answer, so when we calculate the average density, the summation of Fi into Di, we get 230.7, that is approximately 230 kg per meter cube. And the bulk density in kg per meter cube is coming up to 168 kg per meter cube. According to the question, we had 4 different options. So we have our answer as 230 kg per meter cube, which is our answer. And the bulk density, again, we had 4 options. So we have 168 kg per meter cube as our answer to the questions asked. So this is the calculation for the specific weight or the density of solid waste. Our next topic is the moisture content, which is again the physical characteristic of the municipal solid waste. So we have different categories again in moisture content. Now let's begin to understand what moisture content is. The moisture content in the wet weight method of measurement is expressed as the percentage of the weight, which is wet weight of the material. So we also have the dry weight method, and in this method it is expressed as the percentage of dry weight of the material. So these are the 2 different types of measuring the moisture content. One is the wet weight method and the second one is the dry weight method. So we have 2 options to actually measure the moisture content. But what is commonly used is the wet weight method, and we usually use it for all the evaluation of the moisture content in the municipal solid waste. So this is the equation for the moisture content calculation, where we're using the wet weight moisture content method. And this is what we have. Moisture content, which is expressed in percentage, is equal to W minus D divided by W into 100, where M stands for moisture content in percentage, and W is for initial weight of sample as delivered in kg. D is the weight of sample after drying at 105 degrees centigrade. A typical range of moisture content is 15 to 40%, depending on the composition of the waste, season of the year, humidity, weather condition, and particularly rain. This is the typical moisture content values. The components could be the food waste, paper, cardboard, plastics, garden trimmings, wood, and tin cans. And these are the typical range of moisture content and the typical value of the moisture content, which we require for evaluating the moisture content in any solid waste. Let's take up a few examples to calculate the moisture content using the simple formula for calculating the moisture content. So this is one of the questions asked to estimate the moisture content of a solid waste sample with the following composition. So the following composition consists of all the components of solid waste, starting from food waste, paper, cardboard, plastic, gun trimming, wood, and tin cans. And the other data which we have in this question is the percentage by mass. The solution, the steps to calculate the moisture content include, first of all, we have to compute the table with the typical values of the moisture content given. That is the question. Question has to be considered, and the moisture content given in the table is also considered for computation. And the second step would be to determine the dry mass of the solid waste sample using this percentage by mass and the moisture content, which is already available in our question. So for example, we have the component food waste, and the percentage by mass of food waste is specified as 15 and the moisture content as 70. Now, how do we calculate the dry mass? So this is how we calculate the dry mass. Dry mass is calculated using the mass given in the table, that is percentage by mass. First of all, we have to convert this percentage by mass into mass in kg, and then use this mass in kg in evaluating the dry mass. So dry mass is calculated using the value percentage by mass minus the moisture content divided by 100 into the mass in kg. So if we consider the first component food waste, the percentage by mass in food waste is 15 and the moisture content is 70. Now, by using this formula to calculate the dry mass, we have the dry mass of food waste component as 4.5 kg. So in this way, we have to calculate the dry mass for each and every component of the solid waste. And after we calculate, we have all the dry mass calculated for each and every component. So here you can observe the total percentage by mass of these components is 100. And we have the dry mass calculated in the last column, which is expressed in kg. For each and every component, we have calculated the dry mass, and this is also summed up, and the total value of the dry mass in kg is 79 according to this problem. Now we have 79 kgs of dry mass. Now we have to calculate the moisture content using the formula for evaluating the moisture content, which is W minus D divided by W into 100, where W is the total percentage by mass value and D is the total dry mass in kg. This is a moisture content for this particular problem. We had the dry mass as 79 kg. We had the total percentage by mass as 100. Now we have the moisture content as 21% for this particular problem. So this is how we actually calculate the moisture content of solid waste. Let's take another example for calculating the moisture content. This is to estimate the moisture content with a given percentage by mass. So we have the typical values for moisture content given in the last column. These are the typical values, the standard typical values, which we require to evaluate the moisture content. With this, we have to calculate the dry mass of each and every component of the solid waste. Now we know that the dry mass is calculated as given above. And by using this simple formula, we have the last column with the dry mass in kg for each and every component. And the total dry mass according to this table is 60 kgs of dry mass produced by all these components of solid waste. The last step would be to calculate the moisture content using the formula. And for this particular example, where we have the dry mass as 60 kg, we have the moisture content calculated as 40% of the moisture content in this solid waste. So this is our second example. Moving on to our third example. Here we have a table given in the problem. By referring to this data given in the table, we have to estimate the percentage dry weight and the average moisture content of the solid waste. So here in this question, we have two subsections. One is to calculate the dry weight, and the other one is to calculate the average moisture content of these components. Now, the question has, again, 4 different answers. Now we have to calculate and find out which is the correct answer. So to calculate the dry weight, we already know how to evaluate the last column. So this is how we calculate the dry mass. We have the percentage by mass given in the question. We have the moisture content. We also have the typical density in kg per meter cube. And we have to calculate the dry mass in kg. So this is how it is calculated as done previously. And according to this question, the total dry mass generated by these components is 70.4, and the total percentage by mass of these solid waste components is 100. With these values, we have to calculate the next component, which is given in the question, that is the moisture content. Now, if the dry mass is 70.4, we have the moisture content calculated as 29.6%. Now, we have two questions to answer. What is the dry weight of these components? And the answer is 70.4, which we have calculated. The second question is, what is the average moisture content of this solid waste? And we have calculated this as 29.6%. So we have this as an option 1, and our answer is 29.6 as the moisture content. Okay, so this is the solution to the given question, where we had two sub-questions asked in this particular question. Next is the particle size and distribution. The size and the size distribution of the component material in any solid waste is important for us because this is required to consider for the recovery of the materials. The measurement of the size distribution of particles in waste stream is important because of its significance in the design of mechanical separators and shredders. So we find two importance here. One is to consider this for recovery of the material, and the other one is to design the separators and shredders which are required in our solid waste management process. The field capacity. This is again our physical characteristics of municipal solid waste. And the field capacity of solid waste is the total amount of the moisture that can be retained in any waste sample which is subjected to the downward pull of gravity. And the field capacity of waste material is of critical importance in determining the formation of leachates in landfills. So the landfill is the ultimate disposal of the solid waste, and here we see that there is leachate formation, and by having this physical property as a field capacity, we can actually determine the formation of leachates in the landfills, which is a problem in any landfills. So this is the field capacity. Now moving on to what could be the chemical properties of municipal solid waste. So under chemical properties of solid waste, we have again different components. The chemical composition of the components that constitute municipal solid waste is important in evaluating alternative processing and recovery options. So if the solid waste are to be used as fuel, the four most important properties to be known or understood under this chemical property are: one is the proximate analysis, the second one is the fusing point of ash, the third one is the ultimate analysis, and the fourth one is the energy content. So we will be focusing more on the energy content of the solid waste. So the proximate analysis. To know what the proximate analysis is, here the proximate analysis is important in evaluating the combustion properties of wastes or a waste or a refuse which is derived fuel. So here it is important to find out what could be the combustion properties of any waste which we discard. The proximity analysis for the combustible components of municipal solid waste includes various tests, and these tests are the moisture content, where we have the loss of moisture when heated to 105 degrees centigrade for 1 hour. We also have volatile combustible matter. This is the additional loss of weight on ignition at 950 degrees centigrade in a covered crucible. We have the fixed carbon, that is the combustible residue left after volatile matter is removed. And the last component is the ash, that is the weight of residue after combustion in an open crucible. So these are all the components of municipal solid waste, and these are all the tests which are included in identifying the combustible components of the municipal solid waste. The fusing point of ash. The fusing point of ash is defined as that temperature at which ash resulting from the burning of waste will form a solid which is called as clinker by fusion and agglomeration. The typical fusing temperatures for the formation of clinker from solid waste range from 2000 to 2200 degree Fahrenheit, which is 1100 to 1200 degree centigrade. The ultimate analysis, which is also a chemical property or a chemical characteristic of solid waste. Under this ultimate analysis, we have the ultimate analysis, which actually refers to any analysis of waste which is used to determine the proportions of the carbon, hydrogen, oxygen, nitrogen, and sulfur. And this analysis is done to make a mass balance calculation for a chemical or thermal processes. So these are all the typical energy content values which we have. These are the standards. The components again could be the food waste, paper, cardboard, plastic, garden trimmings, wood, tin cans, and the energy content given in kilojoule per kg, which is having a different range for different components, and we have a typical range. So, for example, for food waste, we have a range of 1,500 to 3,000, and the typical value for food waste is 2,000. The component paper could have the range of 5,000 to 8,000 kilojoule per kg of the energy content, and we normally take the typical value as 7,200 kilojoule per kg. For cardboard as our solid waste component, the range could be 6,000 to 7,500, and the typical range, the typical value for energy content can be taken as 7,000 kilojoule per kg. For plastics, the range is 12,000 to 16,000, and the typical value could be taken as 14,000. For garden trimmings, the range could be 1,000 to 8,000, and the typical value can be taken as 2,800. For wood, we can have the range between 7,500 to 8,500, and the typical value which we can consider is 8,000. Anything in between this range can be considered, but these are the typical values which we normally consider. For tin cans, the range is 100 to 500, and the typical value could be 300. So these are the energy content range and the typical values for energy content. Energy content. So we have a question on the estimation of energy content of a typical municipal solid waste. So this is a question where we have to estimate the energy content of a solid waste sample with the following composition. And the question is, what could be the content on the dry basis and on an ash-free basis? So what is the energy content on a dry basis and on an ash-free basis? So here you can observe there are two different questions asked. One is on the dry basis and another on an ash-free basis. So this is the question we have. We again have the components of solid waste, which could be the food waste, paper, cardboard, plastic, garden trimming, wood, and tin can. The percentage by mass is also given in column 2. Here you can observe the percentage by mass for food waste is 15, for paper it is 45, for cardboard it is 10, plastic it is 10, garden trimming it is 10, for wood it is 5, and for tin cans it is 5 again. The moisture content for all these components given in column 3. For food waste, it is considered as 70%. For paper, it is considered as 6%. For cardboard, it is considered as 5%. For plastic, 2%. Garden trimming, 60%. Wood, 20%. And tin cans, 3%. And the energy content in kilojoule per kg is also specified here. For food waste, the energy content is given here as 4,650 kilojoule per kg. For paper, it is 16,750 kg per kilojoule per kg. For cardboard, it is 16,300 kg kilojoule per kg. And for plastic, 32,600 kilojoule per kg. For garden trimming, it is given as 6,500 kilojoule per kg. For wood, it is given as 18,600 kilojoule per kg. And finally, for tin cans, it is 700 kilojoule per kg. So this is the question given, and we have to evaluate the energy content on a dry basis and on an ash-free basis. So this is how we compute or calculate the dry mass. We know that the dry mass is calculated using the formula which we have used previously in computing the moisture content. And we have the dry mass according to these calculations. According to this computation, we have dry mass in kg from the percentage by mass, which is in column 2, and the moisture content data, which is in column 3. So according to this evaluation, we have the dry mass in kg for each and every component of the solid waste mentioned here in the table, and the total dry mass in kg, which is produced by all these components given in the table, is 79 kg. So this is how we have calculated. So for example, for food waste, if we have to calculate the dry mass, we have considered the percentage by mass value, that is 15 kg of the food waste. And we have calculated this percentage by mass and converted that to kg. So for food waste, the percentage by mass is now 15 kg. And if we have to calculate dry mass, we are considering both the percentage by mass and moisture content. And according to this formula, we have 4.5 kg of dry mass produced for food waste. So accordingly, for paper, cardboard, plastic, garden trimming, wood and tin cans, we calculate the dry mass, which we have done in the previous questions too. The second step would be to compute the total as discarded energy in kilojoule of the solid waste sample using the data which is given in the table. Now, how do we calculate this is given here. The total energy in kilojoule as discarded solid waste is given by the formula the percentage by mass of the solid waste into the energy in kilojoule per kg, which is given in our table. So we have all the values of percentage by mass of the solid waste, and we have all the values of the energy content in kilojoule per kg for each and every component mentioned in the table. So with these values, we are able to calculate the total energy in kilojoule for as discarded waste of solid waste. For example, we have food waste as the component in our table, and to calculate the total energy, we can take 15% by mass of the food waste, which is given in the table, and multiply that with the energy content given in the table. For food waste, the energy content was 4,650 kilojoule per kg according to the table. Or when we take the product of these two, we get an estimate of 69,750 kilojoule of the total energy. So with this calculation, we can get the total energy in kilojoule, which is estimated in the last column for each and every component. So initially in the question, we had the column which had the components, the column which had the percentage by mass, the column which had the moisture content in percentage, or we calculated the dry mass. Energy in kilojoule per kg was already given. Now using this dry mass and the energy in kilojoule per kg, we were able to calculate the total energy in kilojoule. So we have both the total dry mass in kg calculated according to this table, and we also have the total energy content, which is nothing but percentage by mass into the energy in kilojoule per kg, which is estimated, and we have the total energy content in kilojoule calculated here. Now, to attend to the two questions which is asked in this question, we have to calculate the moisture content and the energy content according to the question. So our step 3 would be to first of all calculate the moisture content from the given data or the calculated values, and also the energy content. So we know that the moisture content is calculated using the formula W minus D divided by W into 100. And according to this table and the given question, we have 100 as percentage by mass, and we have the dry weight as 79 kg. And according to this calculation, we have the moisture content as 21%. Unit energy content is calculated by taking into consideration the total energy content which we have calculated, and that has to be divided by 100 kg weight of the solid waste. So with this calculation, we have 14,740 kilojoule per kg of the unit energy content produced in this particular combination of all the solid waste components. So the question was to calculate the energy content on a dry basis. Now we have the moisture content of the waste as 21% according to the calculation, and the energy content on the dry basis would be calculated using the simple formula where we have the unit energy content as 14,740. That has to be used in this calculation where we have the energy content on a dry basis. We have 21% of the moisture content, which we have to consider here. So according to this calculation, where we have the unit energy content into 100 divided by 100 minus 21% of the moisture content, we get a total of 18,658 kilojoule per kg of the energy content, which is reduced in the dry basis. So this is the solution to our problem where we have calculated moisture content and the energy content. And this energy content is on a dry basis. So if we have the question on the energy content on an ash-free basis, because in the question they have asked for both the dry basis and the ash-free basis. So this is how we go about when the question is on how do we evaluate the energy content on a ash-free basis. So here we have to assume the ash content as 5%, and the energy content on an ash-free basis can be calculated using this simple formula again, where we have the ash-free dry basis calculated, or we have 14,740, which is calculated in the previous, that is the unit energy content, which was calculated as the 14,740 kilojoule per kg. We have 5% of the ash content considered here and 21% of the moisture content, which we have calculated again here in the previous. That is, the moisture content was equal to 21% when we considered 79 kg of the dry mass. So with this, we have a total of 19,919 kilojoule per kg of the energy content for ash-free dry basis. So that's our solution to the problem where we have calculated the energy content on a dry basis, which is 18,658 kilojoule per kg, and the energy content on an ash-free basis is 19,919 kilojoule per kg. This is our second question. This is asked in few question papers, and the marks allotted to this particular question is 2 marks. Here, the composition of a municipal solid waste sample is given, and the table consists of all the components, the percentage by mass of these components, the moisture content, and the energy content, which is given in kilojoule per kg on as discarded basis. So this is the question. And here, according to the question, there is another question asked in this. Here, the question is, what is the difference between the energy content of the waste sample calculated on dry basis and as discarded basis in kilojoule per kg? And the question uh, is as such. The solution to this would be, first of all, we have to calculate the energy content based on the given values. So we have the table with all the values. So compute a table to determine the dry mass in kg from percentage by mass, and also evaluate the moisture content data. So we have the percentage by mass in column 2. We have the moisture content in percentage. We can calculate the dry mass using both the percentage by mass and the moisture content. According to this question, the dry mass for each and every component has been calculated, and the total dry mass is also evaluated here. According to this question, each and every component has a dry mass. For example, food waste has a dry mass of 6 kgs, paper has 19 kgs, cardboard has 9.5 kg, plastic has 9.8 kgs, garden trimmings 8 kgs, wood 4 kgs, tin cans 4.9 kgs. This is based on the calculation of dry mass in kg. And the total dry mass in kg, according to this calculation, is 61.2. The energy in kilojoule per kg is already given in the question. This is the question where we have the last column of the energy content in kilojoule per kg. So we have now calculated the dry mass. We now have the energy in kilojoule per kg. we'll have to compute the total energy accordingly. So the total as discarded energy in kilojoule of solid waste sample can be evaluated, calculated using the given table. So we have the values given in the table and the total energy content can be calculated using this table, where the total energy is uh, calculated using the percentage by mass and the energy content in kilojoule per kg. So here you can observe that the food waste, which has a percentage by mass of 20, is multiplied with the energy content of 2500 kilojoule per kg for food waste. With that, we have a total energy of 50,000 kilojoule for food waste component. Accordingly, for paper, wherein we have the percentage by mass as 10 and the energy in kilojoule per kg as 10,000, or by calculating the total energy for these two values, we have 1 lakh of energy content for paper component. So accordingly, we have for cardboard, we have 80,000 kilojoule of total energy generated. For the plastic as the solid waste component, we have 1,40,000 kilojoule of total energy produced. Then for garden trimmings, we have 1,40,000 again for the component garden trimming. For wood, we have 70,000, and for tin cans, it is 500. And the total energy, uh, according to this calculation, is 5,80,500 kilojoule of total energy from all these different components of solid waste. So now we have the dry mass in kg. We also have the total energy in kilojoule calculated here in this computational table. Now using this dry mass in kg and also the total energy in kilojoule, we have to compute the next component, which is our answer for the question. Now let's calculate the moisture content and energy content using all the data which is available and all the calculations which we have now completed. Now we know that moisture content is calculated using the formula W minus D divided by W into 100. And according to this, we had the moisture content. We have the dry mass as 60 kg. So by using this dry mass as 60 kg, we have a total moisture content of 40% in our the solid waste component. Now this is our moisture content, which is 40% for these solid waste components. Now the unit energy content is calculated using both the total energy content and quantity of the solid waste mass. That is 100 kg of the solid waste mass we have in this particular question. Now, the unit energy content, according to this calculation, is 5,805 kilojoule per kg. Here we have considered the total energy which is calculated in the last column. The total energy content was 5,80,500 kilojoule of energy. So the same value has been used here. And we have the unit energy content as 5,805 kilojoule per kg. So the energy content on a dry basis is has to be calculated here. We have the moisture content of the waste calculated as 40%. Now we have to calculate the energy content on a dry basis, which is calculated as given below or given here. So the energy content in dry basis can be calculated using the unit energy content, which we have just calculated, which is 5,805 kilojoule per kg into 100 divided by 100 minus that 40% is the moisture content which we have calculated. So when we calculate the energy content in dry basis using this formula, we have 9,675 kilojoule per kg of the energy content. So according to the question, we have to calculate the difference between the energy content of the waste sample calculated on a dry basis and as discarded basis. So we have 9,675 kilojoule per kg of the energy content on a dry basis, which we have calculated. We had 5,805 kilojoule per kg of the unit energy content. The difference between these two will give us the actual answer which we are looking for. So this is how we calculate, and we bring about the difference between the energy content of the waste calculated on the dry basis and as discarded basis. So according to this calculation, we have 3,870 kilojoule per kg of the energy content from this given question. And this is our solution. So the answer for this question, this particular question, is the difference between the energy content of the waste sample calculated on a dry basis and as discarded basis in kilojoule per kg would be 3,870 kilojoule per kg, which is the difference between the calculated values. So if in the question, there is another component, if you're asked to calculate the energy content on an ash-free basis, if this is also a part of your question, this is how you actually calculate. So as done previously, we have to assume the ash content as 5%. So by assuming ash content as 5%, the energy content on an ash-free basis can be calculated. And this is how we calculate the energy content under ash-free dry basis. So we have this 5,805, which is calculated previously as the unit energy content. Now we are using this unit energy content value, that is 5,805 kilojoule per kg of the value, into 100 divided by 100 minus 5 minus 40. That minus 5 is the 5% of the ash content which we have assumed, and 40 is the 40% of the moisture content which we have calculated. So according to this calculation, we have 10,555 kilojoule per kg of the energy content in ash-free dry basis. So the solution to this, the answer to this question would be the difference between the energy content of the waste sample calculated on ash-free basis, ash-free dry basis, and as discarded basis would be equal to 4,750 kilojoule per kg, which is the difference between the calculated value of the energy content on an ash-free basis, that is 10,555 minus the unit energy content, which is 5,805 kilojoule per kg. So this is the uh, calculation part of the different parameters which we have in solid waste. Thank you so much. If you have any questions, you can ask me. And before we get into the actuals, I would like to again take you through few important questions which are normally asked. That is the moisture content. Please remember, this is how we actually evaluate the moisture content when the values are given. So if this is the question given, the first step would be compute the table and calculate the dry mass. So this is how we calculate the dry mass. First of all, we have to convert the mass, which is given in percentage, to kg, and then use this mass in kg to calculate the dry mass. So this calculation is used in almost all the calculations which you have observed now. So please remember the calculation of dry mass, which is equal to percentage by mass minus the moisture content divided by 100 into mass in kg. So please remember this equation. So this is our dry mass. After calculating the dry mass, you have to find out what is the total dry mass for any solid waste component. With this, you can calculate the moisture content, which is equal to W minus D divided by W, where W is the total percentage by mass value and D is the total dry mass in kg. So please remember this formula also. One is the calculation of dry mass. The second one is the calculation of moisture content, which is equal to W minus D divided by W into 100. So this is how we calculate the moisture content. So this is one of the calculations. And another subsection of this was calculation of the percentage dry weight and the average moisture content of the solid waste. So this was the question where there were two sub questions. One was the percentage dry weight and the average moisture content. So we know how to calculate the dry weight, dry mass in kg. So this is how we calculated, and the total dry mass was 70.4 according to this. So in the question, you are given the component percentage by mass, moisture content, and the typical density. You just have to calculate the dry mass value in kg and find what is the total dry mass in kg produced from all these components. So please remember this. So this is the solution to your first question. That is, what is the dry weight percentage in this given mass of the solid waste component? So this is your answer for this particular question. It is 70.4. And the second question was to compute the average moisture content. So here you just have to calculate the moisture content and find out what is the moisture content in that given sample of solid waste. So according to this question and the evaluation, we have 29.6% of moisture content. So you know how to calculate the moisture content, calculate it in the same way, moisture content, which is equal to W minus D divided by W into 100. Calculate that and find out what is the answer for this average moisture content. According to this, it is 29.6% of moisture content. So there are not many questions under particle size and distribution. And under chemical properties or chemical characteristics, we calculated energy content values. So these were the typical values which we have as a standard. And the calculation we have discussed in detail. The energy content, this is the kind of questions you can expect where we have the components percentage by mass, moisture content, and energy in kilojoule per kg. It is usually asked for 2 marks. So here, according to this, they may ask you to calculate the dry mass and the energy content on a dry basis and energy content on ash-free basis. So simple calculation, you just have to calculate the dry mass in kg, or like how we calculated previously. So calculate the dry mass, find out what is the total dry mass in kg, then you can calculate the total energy using the percentage by mass column and the energy content given in the table. So that will give you the total energy content in kilojoule. So this is your total energy content in kilojoule. Calculate the moisture content and energy content. The calculation for moisture content, we know it is simple. W minus D divided by W into 100. For this particular problem, we had 21% as the moisture content. And this is another calculation which you have to remember. Please remember to calculate the unit energy content. Unit energy content has to be calculated using the total energy in kilojoule, which you have calculated in this table. So consider that and the mass in kg, which is again here in our table. So consider these two and calculate the unit energy content. So if you miss calculating the unit energy content, then you will not be able to calculate the rest part of your question. So please remember the calculation of unit energy content in kilojoule per kg. So this is how you calculate. And then using this moisture content, you can easily calculate the energy on a dry basis. So energy on a dry basis can be calculated as such. Now you have the unit energy content. You also have the moisture content. You just have to use these values and also the mass of your solid waste. Using all these values, you can calculate the energy content on a dry basis. So here you have three different calculations. One is the calculation of moisture content. The second one is the calculation of unit energy content. And the third one is the calculation of the energy content on a dry basis. So three different calculations in this step 3. Please remember this. And in step 4, the last step, sometimes this question will be asked or it may not be asked. But if it is asked, please remember that here you have to assume a value to calculate the energy content on an ash-free basis. So we usually assume the ash content as 5%. So again, in this particular question, we have considered 5%. So whenever you are asked to calculate the energy content on an ash-free basis, please assume, don't forget to assume the 5% of the ash content here, and then calculate the energy content. So previously you had calculated the energy content on a dry basis using this formula where moisture content was considered. Here you are just adding another component, that is your ash content, which is 5%. So by using this ash content in the calculation, you get the energy content on an ash-free dry basis. So this is how we evaluated the energy content. So this was another question. The difference here is, here they have asked the difference between the energy content of the waste sample, which was calculated. So the calculation remains the same. The steps are the same, wherein you have the question, which has the component, the percentage by mass, moisture content, and energy in kilojoule per kg. You have to calculate the dry mass in kg. This is the calculated column. So the dry mass has to be calculated for each and every component. Find the total dry mass for all these components. Keep this total dry mass in kg, and then calculate the total energy value by using both this percentage by mass value and the energy content. You get the last column, that is total energy. This has to be calculated, and this has to be a part of your table. Find out what is the total energy of all these components produced. So keep this dry mass in kg, the percentage by mass value, and the total energy content, which is required for our calculation. Calculate the moisture content, which is again simple, which we have done earlier. So calculate the moisture content, calculate the unit energy content, then calculate the energy content on a dry basis. So as mentioned earlier, the step 3 has 3 different calculations, that is moisture content, unit energy content, and the energy content on a dry basis. Here in this calculation, we are considering the moisture content, and later on you will just have to find out what is the difference. So please don't forget the last line, where here the expectation is the difference between the energy content of the waste sample calculated on a dry basis and as discarded basis. So the answer to this question would be the difference. So please don't forget to find the difference between these energy contents. So this would be the solution for your question, where the question will be on the difference between the energy content. It is not actually on the energy content on the dry basis or energy content on the ash-free basis, but it is the difference between the energy content of the waste sample calculated on a dry basis and as discarded basis. So please remember these steps. So this is an additional step. So this was the solution. Now, if suppose the question also includes ash-free basis, energy content on an ash-free basis. So as mentioned earlier, please assume the ash content as 5%. When you assume the ash content as 5%, you'll be able to evaluate using this simple equation, wherein you have considered the unit energy content in kilojoule per kg, and also the moisture content with the ash content, which we have considered as 5%. So here again, the solution should end with the difference between the energy content of the waste sample calculated on an ash-free basis. We are not calculating on a dry basis. Here we're calculating on the ash-free dry basis and as discarded basis. So this gives you the solution to your question. So that's it from my side. Thank you so much. So I can take questions if you have any questions. Well, I'm back. If you have any questions, you can ask me. I can take a few questions. So till then, I'll quickly display whatever we had in our discussion. So this was our section, and we have covered municipal solid waste. The characteristics of municipal solid waste has been covered. The types of solid waste and the characteristics of solid waste has been covered. It is important for us to know what waste is and what burden the earth is carrying today because of all the inventions, the technological advancement, and of course our greed. So the solid waste which we are generating each and every day, and this has grown in years. The quantity is huge, and the solid waste is generated out of each and every activity.
Yes, ma'am. Thank you, ma'am, for the very informative session. I hope the GATE aspirant gained the very informative session on this thing. And the instructions for the GATE aspirants tuned in for next session on structural engineering by Dr. Umesha PK at 3:45 p.m. Thank you all. Thank you, ma'am.